Again, welcome everyone. We're going to give it another minute or so to allow a couple more people to join. We're glad you're all here, so just hang tight. Okay, let's get started. Welcome again, everyone. We're excited to have you join the next installment, which is titled How to Set Up and Verify an ESD Workstation. This is Tom Cerati, president of SMT Supplies, the sponsor for this free Desco ESD Clinic. Before I pass the mic on to Greg Heckler, just a couple reminders. You will remain muted for the duration of the training. That at any time, please type any questions like you did last week into the Q&A feature. If there are enough questions midway through, we might pause and answer those, but we will certainly get to all of them at the end. Each session is going to last for 30 minutes of training and then 15 minutes of Q&A. We'll keep to that time. Greg, it's all yours.
Thanks a lot, Tom. I appreciate it, and welcome back, everybody. Hope you guys found last week's sessions valuable. This one is one of the more important ones of all of them, although they all are, but a lot of people have questions all the time about, how do I test my workstation? How do I set it up, etc., for proper grounding practices, things like that. So that's what we're going to focus on today. Again, these presentations fairly short, so we're going to wait until the end to do the demos. That'll make things go a lot smoother. We also, apologize again for some of the bugs we had last week, but I think we've got all the audio and video stuff worked out, so everything should go much smoother today. So let's get started. Again, I've got Jeffrey Brake here. He's going to be fielding the questions and working the slides for me. So I just discussed this. We can break for questions and answers in the middle, but once again, a lot of times there's some redundancy in that. So you can either ask them anytime you want, or we'll wait till the end to answer them, either one. Okay, so when it comes to, as we discussed before, a lot of the process of controlling static electricity is all about the electrical resistance of the things that we use to control static, like ESD work surface mats, floors, ESD chairs, anything like that where the human body is going to come into contact with it, or grounding the human body, or where the device is going to come into contact with. And in this case, the typical thing that your device is going to come into contact with is your ESD workstation, as in the picture shown here on the slide. So this is a good example of a setup of a typical workstation. As I mentioned before, in most companies, most static control programs, we find there's an average of about 15 to 20 static control items or things that are on a workstation. And one of the main things is the ESD mat, or in some cases an ESD laminate on the workbench itself. So I'm going to talk about resistance of those materials and how that affects static control. We'll talk about some of the types of them, and then we'll talk about setting that up properly. Okay, so when it comes to measuring the resistance, as I showed you a little bit about last week, there are two primary methods of testing resistance for ESD work surfaces, or in some cases you might want to call it the workstation. One of those is what's called point-to-point, or RTT. RTT is the abbreviation for that, and it's how the ESD Association Standard S20.20 defines that. As you can see, now we're showing a tile on top of this workstation here, but let's pretend that's an ESD work surface mat. As you can see, we've got the two 5-pound weights, and we have our digital surface resistance tester here. You can see that we've got this little thing that I'm going to show you when we do the demos. What that's doing is it's separating those 5-pound probes at 10 inches. That's what the ESD Association standard defines for distance for an ESD work surface. So if you want to do it by the book, whether you measure that with a ruler or a measuring tape, or you use a little device like this, if you're going to measure RTT, they should be at 10 inches apart. And the other thing too is, as I discussed last week, the ESD Association standard requires specific test voltages for specific resistance ranges. So anything over 10 to the 5th, for instance, which would be a typical ESD workstation, should be tested at 100 volts. Most testers like this shown in the picture have an auto setting whereby you don't have to worry about that. You just press the button and it automatically decides whether it should be 10 volts or 100 volts for you. Okay, so the next measurement, and this is when we're talking about compliance verification per the TR53 compliance verification standard, like I talked about last week, the main or the required test method for an ESD workstation or work surface is RTG, or resistance to ground. And as I discussed last week, the reason why this is important is because an ESD work surface is really a system. Not only do you have, for instance, the blue mat shown in this picture here, but you also have the snap on the mat, you have the ground cord, and then you have the ground cords connected to your ESD ground. So you're really measuring a system. And that's why it's important that when you make this measurement, you plug your ground lead, in this case is the black one on the tester in the picture, to your groundable point or your ESD ground, and then the 5-pound weight on the work surface itself. As I showed you last week too, which I'll show you again, typically that's right in the center of the mat, but you can test as many points as you want to. Okay, so this is what the standard calls out for when it comes to the test limits or the resistance requirements for compliance verification. I discussed last week as well, there's a product qualification column on most of the static control items, and then there's a compliance verification column. If you were doing qualification, meaning you weren't sure what mats to buy, so you buy a bunch of vendors' mats and you want to test them before you install them, that's qualification. Once that product or any static control item is put into use in your environment, now it becomes compliance verification. So as far as an ESD work surface is concerned, the required resistance to ground is less than 1 × 10⁹. Okay, so that's what you need to know. Okay, Jeffrey?
Sorry, it's me.
Okay, so this is requirements for an ESD control plan. These are many of the static control items that we have in an ESD control plan. And the majority of those items in your ESD plan are usually or typically groundable or need to be grounded. And when something is groundable or should be grounded, the measurement would be less than 1 × 10⁹. So these measurements, these measurement techniques, this surface resistance testing that I'm going to show you that we've been talking about, pretty much most of your static control program is going to be at less than 1 × 10⁹. Now, I did discuss last week also that there is a recommendation in the standard that if you are concerned about CDM or charge device model damage, that a work surface have a minimum of 1 × 10⁶ or 1 megohm of resistance. But remember, there is no requirement for that. It's a recommendation if you have a CDM concern. Okay, meter types. Some of you may have this type of tester. They've been around for a long time. In fact, the original surface resistance testers were similar to this. If you were to turn this tester over, you would see these 2 parallel bars that are about 4 inches long on the bottom of the tester. And so these testers in the early days were just designed to measure resistance in ohms. And now they've been modified a little bit. Now they have the 10 and 100 volt required test voltages, and they have banana jacks so you can plug 5-pound weights in. But this type of tester is really just a checker if you just want to casually verify resistance of something, okay? But this is one type that you may have, and one of the ones that I want to talk to you about. This would also be the less accurate tester type. The next type would be an analog instrument. Now we're stepping up in accuracy, okay? The only difference between this tester and say my digital one, it's got an analog scale and there's no mantissa or the fraction of the exponent. So you'll see what we've done with this tester. We put the yellow and green and red settings on the analog readout. And if all you care about is that it's less than 1 times 10 to the 9th or some number below that, then anything, for instance, in that green scale is going to be good. So this may be all you need when it comes to, you know, testing resistance of your static control program. But if you want to know what the mantissa or the fraction of that exponent is and step up in accuracy, you really need a digital instrument like the one I've used last week or similar to this one. As you can see, the accuracy steps up here. It's got the auto setting for voltage, for the voltage measurement or the voltage test requirements. Also, it's got an LED and an LCD readout. So what we've done here with the LEDs, we put kind of the same colorization as we do on the analog scale. So if you saw in the green, you can just move on your way. But if I wanted to know if it was, for instance, 5 times 10 to the 8th, then I've got my LCD scale there also. Also on this tester, as with some of the higher end testers, this has a memory function as well for test results. Okay, Jeffrey? Okay, so let's talk about materials in work surface materials or workstations. First, we're going to talk about conductors. Now, most of you, I mean, you're all in the electronics business. We pretty much all know that a conductor would typically be metals of some type, carbon-loaded things, copper, silver, gold, etc., or some type of material that has a high volume of carbon loading to make a conductor. But typically, when we're talking about things like this, conductors, dissipative insulators, they represent an area on a resistance scale defined by the S2020 standard. So for example, a conductor would be something that's less than 1 times 10 to the 5th or 10,000 ohms. And as I show in my presentation here, conductors, when you have them, they should be grounded, because as a conductor that's not grounded is basically a capacitor. So if I charged up a conductor, it can hold that charge unless that charge is grounded away. So there are times when we might want a conductive work surface, for instance. But as I discussed last week, if you're concerned about the CDM threat or the charge device model threat, then you wouldn't want a conductive work surface. For example, that might be a stainless steel workstation in a clean room. There may be reasons why I need the stainless steel workstation for cleanliness, so that would be okay, but you'd want to make sure that you don't have a CDM threat. Now, insulators on the bottom, that's the extreme, that's the exact opposite of a conductor. An insulator is something that doesn't have any type of metal surface or conductivity to it to allow the electrons to flow across it. So as I described last week, and Jim's going to touch on too next week, is that conductors cannot be grounded. So those are the two extremes. So now I'm going to talk about the one in the middle. Okay, so well, I just described this. This is an example. Oh, I'm sorry. So let's talk about dissipative. The word, obviously, to dissipate has been around a long time, you know, since the beginning of the English language, basically. But when it comes to ESD control, it was specifically created as static sensitivity components became more sensitive. So now there became a need to control how quickly we dissipate that charge. So in the old days, we had anti-static pink poly, and we had carbon-loaded conductive polyethylene. And as components became more sensitive to the CDM threat, we wanted to control how fast we dissipate that charge. So then now we created dissipative types of materials. And those materials are in the 1 times 10 to the 4 to less than 1 times 10 to the 11th. But when it comes, and this is important because this confuses a lot of people, when it comes to a groundable item, that needs to be less than 1 times 10 to the 9th. So even though the word dissipative goes all the way up to 10 to the 11th, anything that you're going to ground or use to ground things with needs to be less than 1 times 10 to the 9th. And that's a work surface. When it comes to the human body, it needs to be less than 3.5 times 10 to the 7th. So that would be you wearing your wrist strap, for instance. And when it comes to ESD flooring and a person standing on it, you need to be less than 1 times 10 to the 9th, as well as the person standing on it. So all of those ranges fall into that static dissipative range. Okay, Jeff?
That's it.
I think that might be it. Okay, so we're gonna
Oh, yeah.
kind of highlight some of the things on a typical workstation. You can see obviously a workstation mat. Now, we talked a little bit about what an ESD work surface is versus a workstation. So a work surface is anything that your ESD sensitive device is sitting on. That could be your static shielding bag if it was sitting on the workstation, or a tote box or whatever. In our case, we typically think about soft ESD mats or an ESD laminate. But there could be all these different things, from packaging materials to grounding hardware. You've got testers and monitoring equipment associated with your workstation. You can see up on the top here, we've got an ESD cleaner, we've got ESD binders, those types of things. But for this presentation, we're really going to focus on the work surface as the workstation and the testing.
These are the options.
Okay, and then we've got floor mats. Again, that's a thing that we typically are going to have if we need to ground either an ESD chair, a mobile human body, a cart, for instance, that maybe is going to roll on top of a mat. Maybe you've got anti-fatigue mats in front of your SMT line, things like that. Floor care, maybe you use an ESD floor finisher, you have a conductive floor. So those are all groundable things that involve the process of measuring resistance.
I think that's the last slide.
Okay, so I think that's the
We'll
last
do the demo
one.
now.
So we're going to go to our demos now.
Let's get this set up here.
Go to the camera.
Take that down. Let's see.
Bear with us a
And
second.
I think you're on. I just want to make
You're
sure
on.
that
You're on.
they can see. They can see. You
Okay,
can see
I
good,
just-
Tom. Okay.
I can't.
We're
see
good.
it.
I don't understand why we can't see it here.
Yeah, you got it. If you can't, if I'm not holding the product up right until we get this corrected, it's okay that you guys can see it.
Okay.
So again, I have my typical ESD workstation here. This is, many of you might have this exact same bench. It's very popular in our industry. I've got my ESD survey kit setting up here, but today I'm really going to focus on my surface resistance tester, the probes, et cetera, that I was talking about. And now this time I've got this gray dissipative workstation mat. It happens to be a 2-layer rubber. Again, it's easy to know. It's a color on top and it's a black conductive layer on the bottom. I've also got another piece of 2-layer rubber material that's not grounded. And I have one of those kitchen cutting boards that I talked to you about last week when you're measuring insulators, or you want to isolate something from your grounded workstation or something from grounded. So one of those kitchen cutting boards makes a great tool to be able to do that. This here is that 10-inch little adapter, little tool that we sell that you can separate your 5-pound weights with. So I'm going to do that first. Back here, I've got a AC outlet analyzer, which is telling me that my ESD ground and AC outlet is in spec, as well as the proper polarity. So I'm going to use that my ground point. But if you were doing ESD measurements at your workstation, for instance, and you have the place where you plug your wrist strap in, as long as it's not a continuous monitor, but if it's a regular ground jack, you could also use that as your ground point if you want to also. So I'm going to use this one because it's convenient. All right. Now, this is the RTT measurement that I was pointing out. Why do I put it in the center of the workstation? Because that's pretty much where everybody works. All right, if you were to look at your ESD mats out there now, unless they're brand new, you could probably walk out in your assembly environment and you'll see there's a worn area or a dirtier area right there where everybody works. So for compliance verification, test the most worn area first. If that is out of spec, then test a clean area. If that's in spec, then you know that it's probably a dirt issue or a contamination issue, but go to that spot first. So I'm going to run my test. This tester also, so you got I'm going to try, I can't see if you can see this because I don't have my camera, I'm sorry. But what I'm showing here is I'm showing 9.34 times 10 to the 6th. So is that less than 1 times 10 to the 9th? Yes. So I can move on. But again, a digital tester, I've got my green LED so that I know that's good, but I also have my mantissa or the fraction of the LED if I want to know what the exact measurement is. However, like I said in the presentation, the most important part or the mandatory test requirement for an ESD workstation or an ESD work surface is resistance to ground. And for that, I only need my 1 probe and I need my connection to ground. All right, so I'm going to go back and run this. Okay, 5.59 times 10 to the 5th. So why is my RTT measurement less than my resistance to ground measurement? The reason for that is because now, once again, I'm measuring the volume resistance of this material, not just the surface. So now I'm measuring the dissipative top, I'm measuring the conductive bottom all the way to ground. So when I have a good ESD work surface material like this that has a ground plane, that RTG measurement will almost always be less than the RTT. But let's say this failed. The first thing I would do is make sure that it's grounded, which is back here. The second thing I would do is now bring my other 5-pound probe in here, and I would measure the RTT to make sure that the surface of the mat isn't the problem. So that's just some quick tips about that. But you always start out with RTG first and work your way backwards. Now, let's say I'm going to use this right now to demonstrate whether if my mat was grounded or not. Let's say this is my workstation and I've got it sitting over here. I'm going to put my 5-pound weight back on top of there and plug my tester back into ground. And I purposely not grounded this. So I'm going to run my test. Okay, now it's going high. And this tester has a little white bar. When it goes over 10 to the 10th, it automatically switches to 15 seconds of electrification. So now I've got a test that's 5 times 10 to the 10th. So it's out of spec. So now I'm going to look around and go, oh, no wonder it's not grounded. I'm going to unsnap my ground cord. I'm going to bring it up to this mat now. I'm going to rerun my test. 1 second. Okay. So this is a 2-layer rubber, just like the other material is. 9.66 times 10 to the 6th. So all the problem was that it wasn't grounded. So when you're doing your measurements and you run into issues where you get over 10 to the 9th, first thing you want to do is make sure it's grounded. Second is check that RTT or surface resistance of the material. That's one of the most important things. There may be other things, but those 2 things will give you a clue as to what's going on. Okay. What should okay, let me show you something else too. I mentioned last time a little bit about insulators, but you could also think of them sometimes as isolators. Sometimes, I think even somebody asked a question last time about paperwork. Again, paper, this is just cheap wood pulp copy paper. It's not a big static generator, hardly any at all typically, especially when the humidity is high like it is now. But if I were to put it on my ESD work surface mat, I'm going to ground my mat again. Okay. and I go, and if I were to set my circuit board on there, now what I've done is I've isolated the circuit board, which that and the electronic component leads are conductors. I've isolated them from ground. So I'll go back and check this. Okay, so now I've got 9.9 times 10 to the 10th. Why do I even have 10 to the 10th? Well, the paper's probably absorbed a little humidity, and I've got a ground plane. But once again, I'm not in spec. The number needs to be less than 1 times 10 to the 9th. So this is one of the reasons also that the standard requires that if I'm going to measure something like a static shielding bag, packaging materials, or if I'm going to measure the surface resistance of something, I need to put it on an insulator. And this kitchen cutting board's about 10 to the 13th. So that's the importance that if I'm going to measure the resistance of some isolated thing like this, I want to really isolate it. Paper, for instance, it wouldn't be uncommon to say get 10 to the 10th if there's even a little bit of humidity in there. So that's, so do we have any questions, Jeffrey?
That was, the one question was to the paper question, essentially. What can you, can you show, I don't know if you can show this, but can you show the difference? I think we can do it with the tile you have there,
okay,
of compliance verification and what product qualification testing would look like.
Okay, that's a good question. So there are a couple of main requirements for, I've got a conductive floor tile here, main requirements for compliance testing for almost every static control item, and that's temperature and humidity control. For just about everything, there's a requirement to test at a minimum of 12% humidity and a maximum of 50% humidity. There's also, I think it's 72 Fahrenheit. So unless you have a humidity chamber or a way to control that, it's going to be hard for you to do the qualification for yourself. So again, like I mentioned last week, really it's so much easier just to buy pre-qualified materials. But for 2021, you actually have to have the manufacturer's test report on that. So that would be something we would be able to provide for you. But the other requirement is that you have multiple test samples. So for instance, I might have to have 4 or 5 of these, 12 by 12 tiles. I might need to test multiple places on this tile. I'd have to test for surface resistance and resistance to ground, whereby TR53 compliance, once I said that's the mat I'm going to use, and I cut it up and put it on my workstation, ground it, all that's required is resistance to ground. If I fail my resistance to ground, then I work backward, as I said, my RTT, check for a ground connection, things like that. So if you want to do your own qualification, that's fine, but the tough part's going to be temperature and humidity control. So that's an excellent question. By the way, while I've got this tile, I also wanted to mention that if you have an ESD floor, one of the things that you might notice is that you have to put your 5-pound probes at 36 inches apart for RTT versus 10 inches apart for RTT. It's 10 inches for work surfaces, 36 inches for flooring. And the reason why that is when these conductive tiles first came about or were first invented, the way a conductive tile works is all this little carbon grid here. And the only way to tie all that grid together or tile to tile together is with a conductive adhesive, or like the ground plane on the bottom of the mat. So if I were to only test from here to here or 10 inches, I would only know if this tile is good. So when I test at 36 inches, I'm making sure that all my tiles are connected. So if you have a conductive vinyl tile floor, you want to make sure you're testing at 36 inches. If you have an ESD floor finish, that kind of thing, it doesn't matter that much, but the standard still requires 36. So that's why we make a long 36-inch one of these as well. Any more questions? Yep.
Can you show somebody asked what the temperature and humidity is today?
Today?
Yeah.
The
meter has it, right?
Yeah, 75 degrees, 52% RH. And that's why this paper is soaking up a lot of humidity. In fact, that's an excellent question, especially on a day like this, because I can actually demonstrate that fact. That's why this paper is so conductive right now. Don't be surprised that if you had your 5-pound weight sitting on your conference room table, that it read 10 to the 9th. That's not an ESD work surface, but you're still measuring the conductivity or the resistance of the moisture that's sitting on everything. Remember, humidity is everywhere. It's all over the bench, it's all over the top, it's all over me. So don't be surprised that you might get that. And that's another reason why RTG is so important. Because yes, I care about what the surface resistance is, but I care about whether it's less than 1 times 10 to the 9th to ground. So that's a good question. Any others, Jeffrey?
Somebody would like to ground it. Sure. How would you test a chair?
Okay.
Maybe we can move this over there.
Yeah, I can move this over here. So
This is an ESD chair right there.
Yeah, I can't show you, I can't move the camera right now, but I actually have a conductive ESD floor that I'm standing on right now. So this actually, this one is not, Jeffrey thought it was an ESD one, but this one isn't. But if, like anything else in my ESD program, when I'm measuring RTG, it doesn't matter whether it's the cart over there or the chair or the floor or whatever it is, I'm always measuring the resistance back to ground. Some of you might take your other 5-pound probe and put it on the floor and one on the chair. That's not the measurement requirement. It's resistance to ground, okay? So it's no different. All I do is put my 5-pound weight on the center of the chair, my other probe to ground, and run my measurement, and that should be less than 1 times 10 to the 9th. That's the same process for the cart over there, for a shelving unit, anything that I'm measuring resistance to ground. Okay, Jeffrey?
So I think that's the last question. Maybe since, is the cart connected to
The
ground?
cart is grounded. Actually, we have, this is one of the carts out of our lab, actually. So I have the Metro style wire type shelving cart here. As you can see, this is pretty popular in the business. I actually have an ESD mat material on top of it. In this case, this cart is grounded with ESD conductive casters on the bottom, but I also have a drag chain here that would be very common that are used. We talked a little bit, I think, about drag chains last time. So again, the same measurement process. Unplug this, making myself a little bit of a rat's nest here. So again, grounded point, 5-pound probe on the surface of the material. I'm gonna run my test. So automatically I'm getting a 7 on the LED readout, 1.44 times 10 to the 7th, less than 1 times 10 to the 9th. So I could talk a little about tricks again. Remember that the cart itself is not the work surface. The work surface is the mat that you put on the cart. So whether you're checking the bare metal or whether you're testing the mat, it's still the work surface. Like a work surface here, if my RTG would fail, I would make sure my cart's grounded. I make sure my shelf is bonded to one of the legs, and I make sure the cart is connected to the floor somehow. In this case, it's the conductive casters. Also, I got one of these little things here that this clamps around the post of the cart, so it bonds the shelf to the leg. These are really convenient to use for that. But this is probably the most challenging thing to ground in an ESD environment. More people have problems with consistent grounding of carts than anything. It's really easy to put a snap and a wire on here, but when you're grounding things that are mobile, there's a lot of other things to come into play. So there's some, you know, if this wasn't in spec, the first thing I would do is check the RTT of the mat. The second thing I would do is check the resistance of the floor. I check to see my casters are conductive, or that my legs are bonded to the shelf. So the whole process there, but I always start out with RTG first. Okay, Jeffrey?
That's all the questions we have. Tom, do you have anything else?
No, I think, did we cover the topic the way you wanted to, Greg? So set up and verify an ESD workstation, right? I think you've gone through it all.
I think so. Those are all the verification measurements. Sorry, Greg, I didn't mean to.
No, that's okay. I did want to point one thing out, so I'm glad you mentioned the word setup, Tom. Sometimes, or lots of times, we get questions, do I need to cover the whole workstation? Well, that's up to you. It depends on what and where you're going to set your ESD sensitive devices. If I was only going to work right here, maybe a 2 by 3 foot mat on a 6 foot bench is all you need. But if I'm going to set my ESD bags over on this corner and a tote box on that corner with product in it, or my other conductors or whatever around the workstation, you should try to cover the majority of the workstation. That also makes it kind of a no-brainer. So no matter where that person sets that conductor or that static shielding bag or wherever it is, it gets grounded. So that's also a common question we get asked. It's best just to cover as much of the workstation as you can. It also makes a much more comfortable surface to work on, whether you're leaning your arms or things that don't roll off easy, something like that. So those are a couple other little tips and tricks of the trade, if you will.
Gotcha.
Okay, Tom?
Very good, Greg. Great stuff. Thanks for clarifying that. All right, everyone. We hope you found the second one to be beneficial as you did the first. And we look forward to having you all attend next week. That's next Wednesday, September 21st at the same time, 11:15 a.m. Pacific Standard Time. Greg mentioned we do have a surprise trainer next week. Jim McKeon has been with Desco for over 33 years in various roles, including National Sales Manager. Currently, he's the training expert within Desco industry. He will be doing the training next week. Greg will be attending the ESD show up in Reno, Nevada. And then a reminder to everyone attending, we still have the 2 promotions from SMT Supplies that we'll be conducting at the end of the 4 weeks. The first is the 10% discount on single purchases for almost anything on our website, with a couple exceptions. And the second one, your name will be entered into a drawing to win the new Desco dual operator single wire continuous monitor. That's valued at $235. But as a reminder, to take advantage of both, you will need to attend all 4 sessions. So thanks again for joining. Greg, Jeffrey, thank you, everyone. We'll see you next Wednesday.
Yes, and one last thing, I'm sorry, Jeffrey. One last thing, Tom. If you guys have more questions, just email them and I'll answer them for you in writing also. So
Very good.
Thanks a lot, everybody. We appreciate it.
Thank you.
Bye, Tom.
Bye, guys.